Thanks for the intro. Thanks everyone for being here. Today I'm going to be talking about our efforts to try to put a price tag basically on the invasive annual grass management aspect of the sagebrush conservation design. So if you're not familiar with the sagebrush conservation design, or what I'll start referring to as the SCD, this is a map generated from it. And the idea here is that they evaluated ecological integrity of the sagebrush biome and develop these different classes. So there's core sagebrush areas, growth opportunity areas, and other rangeland areas. And the idea is that they can help guide this strategy that's been kind of behind a lot of sagebrush conservation lately, defend the core, grow the core. And so we asked, well, what is this going to cost on a multi-year basis for the invasive annual grass management component of it? There's other threats, of course, that this biome is facing, so we're just looking at this one slice of it. They, to help translate these defend and grow type actions to a spatial footprint, they've got this nice little table over there where defend is related to core and growth opportunity areas that have a low level of threat, and then grow is where there's a moderate threat. And then as you move out towards the other rangeland areas and the higher levels of threat, you start getting into mitigate type actions, where instead of trying to invest a lot in intense restoration, you're just trying to mitigate the impacts of the invasion on those core areas. So the simple way of putting a price tag on this would just say, well, how many acres under each of these categories are there? What do those cost per acre? And just calculate it all out. But I know, as many have mentioned, these things aren't static situations. So plant invasion is a dynamic process. We've got the invasion spreading into new areas where there wasn't previously invasion. And then we've got low-level invasions that are becoming a higher level of cover within a particular site. And then at the same time, you've got people treating these infestations, and it's back and forth in this interactive dynamic process. So that's where we bring in state and transition simulation modeling to look at how the ongoing spread of the invasion is going to be impacted by treatments and back and forth. So our objectives were to characterize these treatment costs as a function of infestation level and site condition, and to compare these costs over a set of different treatment allocation scenarios, and then also develop a spatial layer trying to estimate these costs across the biome. So to start with, we built off a state and transition simulation model developed by a colleague of ours who's working on this project with us, focused on buffalo grass in southern Arizona. But that's a pretty different question from what we were working on with cheatgrass and other invasive annual grasses across the sagebrush biome, and also was at a much smaller spatial scale. So we had to update this model in a lot of different ways. In terms of the rate of spread and infill of the infestation itself, the different ecological conditions and how those might influence management actions, as well as costs and efficacy of treatments. So we began an expert elicitation process to try to figure out some of these parameters, the model development itself, tweaks to the previous model, and developing different scenarios that would be useful for informing management. And this was an iterative process where we're bringing stuff from the literature, thinking how we're going to construct the model, proposing it to the expert panel. They give us feedback. We make some tweaks. We come back. Does this make more sense, et cetera? And there's a lot of existing data out there that we're pulling from. So we've got, for initializing the model, the baseline layer of cheatgrass infestation. We're using the rangeland exotic plant monitoring system. So we have cheatgrass cover estimated from that. And then we're bringing in habitat suitability from Inhabit to map where it might potentially spread to. And then to figure out how that spread happens over time, based on input from the expert panel, we decided to use some of the resistance and resilience, conceptual work that informs a lot of sagebrush management. We didn't actually use any of the tools for that were already developed. We actually put together our own thing based on a soil climate product that was recently released from our lab, and then integrating that with perennial herbaceous cover, because a lot of this R&R stuff is just abiotic focused, and the expert panel felt like the biotic component of that process was really important to include. So we brought that in. And then we're also looking at how to spatially prioritize the different treatment actions. The SCD doesn't necessarily tell you what to go do and where exactly. There's this map that helps inform that, but it's not a prescription. So this was another thing back and forth with the expert panel trying to figure out what are these different scenarios going to be, what are we going to do where based on these different SCD classes, and then also thinking about distance to certain classes such as the core sagebrush areas. That's an important consideration. And then the R&R stuff comes back in, not only determining the rate of the invasion spreading, but also where we're going to prioritize treatments based on R&R level. Yeah, so the box on the right there, the blue box, is basically summing up the different scenarios we came up with based on all this other stuff. And sorry that this is, I feel like I'm just blowing through this, but we've got a lot on this presentation here. So we've got 3 scenario sets. So the first one is kind of a baseline thing that we can kind of measure success based on, a no management scenario. What happens if you do nothing? It's sort of apocalyptic. And then a reactive scenario where it's kind of a whack-a-mole. There's cheatgrass, let's get it, and it's not spatially prioritized. And then we have the next set that is so we have 2 sets that are SED informed, and one of them is with an unconstrained budget. So trying to get an idea of what this might cost in total, and then working back down from there. And we have 3 scenarios in each of these 2 sets, the constrained and the unconstrained. And so one of them is, let's just focus on the core sagebrush areas. What happens if you just focus on those and don't worry about the other areas? And then the second one is bringing in the growth opportunity areas. And the third is bringing in those other rangeland areas. And this is the conceptual model we ended up with after modifying that initial one that we started with from the bufflegrass project. And don't have time to get into all the nuts and bolts of it, but basically there's an undetected invasion going on, and then there's inventory actions that can bring those undetected cells into detected cells that can then be treated. And we've translated these defend, grow, and mitigate actions into specific treatments. So we decided defend was basically an early detection, rapid response type treatment. Grow is doing a more traditional aerial herbicide application, generally followed with some sort of native grass seeding. And then the mitigate is just the herbicide application where you're not really trying to get invested in a big restoration project, but just mitigating those impacts. This was an interesting takeaway, and this was one of the surprises for us. This slide, we're looking at the costs here, and you may notice that those are just flat per acre costs that we're putting up there. We went to the expert panel with all these covariates of how we thought costs might vary across the landscape based on various different conditions, based on the preliminary results of some economic analysis we were doing on a different project. But through talking with them through multiple meetings, we slowly kept removing this covariate, that covariate. They didn't feel comfortable. There's not enough data to really support including this in the model in an explicit way. And we walked away with it with no covariates left for our costs. And so there's just these flat estimates, which we were a little uncomfortable with, but sometimes, adding more information is just adding more noise. So that's where we're at now with it. And just a reminder, this is all still very preliminary, so it's not finished. We also, this figure here is illustrating the spatial prioritization that we used. And so the dark green is those core areas where we're trying to treat all of those. And then growth opportunity areas are in different shades of green and purple on there, changing as they get further and further away from the core areas. And then the other rangeland areas are depicted in the same way, but they have an important limit on them, where once we get 30 kilometers away from a core sagebrush area, we're not treating them anymore because we're just trying to mitigate the impacts in those areas on the core sagebrush areas. Even with all those limitations, what we were trying to do was too much. So we were trying to simulate all this at 30-meter resolution across this whole biome, and it was not working. And so we are now in the early stages of figuring out a sampling strategy for this. And so we've got these ecoregions we want to take into consideration in our sampling design. And then we've brought in these climate clusters in the center graph here. They were developed for informing greater sage-grouse management. And they kind of relate to the ecoregions, but they're a little different. And one of the strengths is that they're hierarchically nested. And so we can pull out the neighborhood clusters on the last slide there. We can use those as sampling units and then hopefully extrapolate out to these climate clusters. And this is a work in progress. We're trying to explore a couple of different approaches to this, but that's what we're going with for now. And our preliminary results I'm about to show you are all from this neighborhood cluster in Southwest Idaho here. And these are the spatial prioritizations. Again, those core areas in green, and as you're getting out further away, they become lower priority, but it's trying to apply management as most to those areas as it can. And then these are some of our initial results, and there's a lot of ways you can potentially quantify treatment efficacy in terms of controlling plant invasion. Here we have the amount of invaded hectares left in left in each of these different SED classes as you're going across our 30-year simulation in time. And the core areas are on the left. And what we're seeing right now is that we're not really having an effect except on the unconstrained budget scenarios. So it's based on our cost estimates, it's costing a lot, and our lower, more quote unquote realistic budgets are apparently not enough. And then on the bottom right, you've got the growth opportunity areas where we're seeing a similar story play out. And then on the top right, the other rangeland areas where there's no effect, not even in the unconstrained budget, which actually makes sense. It's not really surprising because we're really limiting how much treatment we're applying in those other rangeland areas to those buffers around the core areas. In terms of costs, we get pretty flat rates in those constrained budgets. The unconstrained budgets, they dump everything into just treating the whole landscape right away because they have no budget constraints. Obviously, that's not very realistic. So one of our next steps is trying to go back and figure out temporal allocation of these budgets while trying to account for an unknown quantity of money that we need to be spending to actually make a difference. So there's going to be another iterative process here of figuring that out. This gets a little more into the meat of it. I draw your attention to the black and white symbols. Those are the totals for the SCD classes. The ones with colors are showing the R&R level in each of those. And on the left here, we've got the scenario focused on the core sagebrush areas. And this little guy right here is showing that we're really effective at defending the core in this scenario. We've got no cheatgrass at the end of the simulation. And I'm sorry, I should explain the axes real quick. The x-axis is the cumulative cost over 30 years of treatment. The y-axis is the invaded cover in the last 5 years of the simulation. So this is trying to show like the effect over 30 years of implementing all this. And we're able to bring those core sagebrush areas to no infestation left. When we go over to the middle graph there, the growth opportunity areas, if you look at that hollow circle there, you can see it's way down on the y-axis versus in the CSA scenario. So we've gone from almost 180,000 hectares of invasion to less than 50,000. So potentially we've taken the first step in growing 130,000 hectares of sagebrush habitat. So that's pretty interesting, but it is coming at a very high cost too. And then on the other rangeland area, you're seeing similar thing there where there's not really effect in terms of the invasion and you're spending a lot of money. So that may seem like a waste, except again, that hollow circle on the right there on the bottom has gone down to under 20,000 hectares. And so we need to explore a little bit more what's going on there. But what we're thinking might be happening is that's the effect of that mitigating those other rangeland areas and keeping spread from coming back into those growth opportunity areas. And you can see that when we look at it spatially. The dark blue is showing at the end of the simulation all the areas that were previously invaded but no longer are. So in the core only, you can see that we're really effective at defending the core, but everything else is turned to just total cheatgrass. When you go to the middle scenario where you add the growth opportunity areas, we're defending the growth opportunity areas now, but we still have a lot of cheatgrass out there, and it's a lot of high infestation in that interstitial space along the borders. And what I think is really interesting is you can see those buffer zones on the right side there. There's the buffer that's kind of going from orange to blue and such. And so that's potentially out in that other rangeland area, not great sagebrush habitat, but it's creating a buffer that could be really useful for helping manage and protect sagebrush from things like wildfire. And yeah, so I made it to the last slide. So takeaways, a lot of this is, this is still in development. We're still going back and forth to the expert panel. And, we're walking the tightrope of model complexity versus model realism and thinking about things like parameter uncertainty. Sometimes adding more information is just adding more noise. And that's kind of what we found out with the costs, the cost covariates. And then computational capacity. High resolution data is great until it crashes the supercomputer, and then you've got to figure out something else to do, right? So we're working on that. And, the cliche of, all models are wrong, but some are useful. That's what the expert elicitation panel has been really useful for us, trying to make these decisions between complexity and realism in a way that keeps the model useful for managers. And then, yeah, results to be determined, but it seems like not enough is happening right now. We're not spending enough money, and without an increase in budgets, spatial prioritization may not be enough alone to help. And so we're working on continuing to validate the sampling strategy, figure out those different midpoints in the budgets and temporal allocation, and then extrapolate that all out to the biome to get a full price tag for this. So thanks.